Hello again and welcome. I'd mentioned previously that once we hit 2,000 subscribers, I started a poll up on the EEVBLOG site. My intention with that was to allow viewers to vote on a particular meter that they would want to see ran. The vast majority voted for Dave's EEVBLOG 121GW. Unfortunately, this meter is not available to the public yet, and we also don't know what its release date is. So I started to look at the second most popular meter in the poll, and that was from Gossen Metrawatt. So I started looking at the different meters that they offered, and I narrowed it down to three. I wrote some friends of mine about it, and the three I'm interested in are the M205A. This meter costs $243. It's 6,000 counts. It's really a basic meter. So I had mentioned to my friends that if I want this route, it's kind of like buying that low-end Hioki. It's just to kind of give you an idea how the meter does. So my friends were basically saying that if we went with the lower cost meter and the meter did poorly, that subscribers may feel that we really didn't give Gossen a fair shake. And I don't know. I mean, maybe that's true, maybe it's not. I would hope that Gossen would actually make very robust meters, and it really wouldn't matter if we bought the lowest end meter or the highest end. But again, as we've seen with Fluke, the 87V did very poorly on the test. And all the other Flukes that I've looked at, which were very low cost, actually did quite well. The next meter I looked at was the M248A. It has a cost of $732. It's 310,000 counts. The problem with this meter is it can't measure conductance. It also can't measure two temperature inputs. It doesn't have a bar graph. It appears to have a AC plus DC mode, but it doesn't appear that it can display the separate values all on the tri-display. So while it is a tri-display meter, it seems like they really haven't done a good job utilizing it. They do offer a Bluetooth version of this, and they also have some LabVIEW software available that may be able to be used to interface with the meter. The last meter I looked at was the M249A, and this is $1,053, and it's 60,000 counts. Looks pretty nice. It can measure power. Dave did a review of it, and unfortunately I wasn't real impressed. The meter they tore apart had a tacked down axial resistor laid across it. You know, you're paying that kind of money for a meter, I expect that thing to be flawless. So I wrote up on the EEVBLOG to see if Dave actually knew if that meter was a prototype or not, and it sounds like he never really found out. But another member posted, and they had recently purchased one of those meters, and they took it apart, and indeed the resistor wasn't there. But unfortunately, they also said that they weren't really impressed with the meter. It sounds like they never even really use it. The user interface makes the meter very difficult to use, and they were basically saying they always had to have the manual nearby to use it. And that's kind of unfortunate. You know, if I get a meter, I don't care which one it is, but I'd like to be able to just sit down with a meter and use it. But you know, some of these more complex meters, especially one that's going to be capable of measuring energy, you know, you got to imagine there's probably a finite number of buttons on this, and it's going to have some kind of a menuing system. So it could be fairly difficult. I think they did a real good job with this Unity UT181A. They basically stole Fluke's user interface. But you know, this is very self-explanatory. I never owned the 289, but I could tell you, you know, for me, this is very user-friendly. So I would hope that the Gossen would be the same thing, but the problem with the Gossens is they don't have this nice graphical interface, so making a complex user interface like this would be a lot more difficult. So I downloaded the manuals for these meters, and these are just some of the pages that I printed off out of the M248A manual. So I highlighted a few things that I thought were pretty interesting. One of them, I didn't know anything about how Germany does their calibration, but you can see they have this calibration seal, and it looks like this is actually printed on the meter. But they have this data calibration, so I suspect when you purchase one of these meters, you actually know when this thing was calibrated. And you can see it's a 310,000 count meter in the DC volts, DC amps, resistance, and frequency modes. It's 31,000 counts in the AC volts, AC plus DC, AC plus DC current, and AC current. And when you're measuring capacitance, it's 3,100 counts. So if we go to the next page, and right here for volts DC, I'm expecting this thing to go to the 310,000 count mode. And right here for 300 millivolts, it's got this little asterisk, and it says via manual measuring range selection only. so they won't just auto range down to the 310,000 count mode. And I'm kind of used to that with this Bryman. You actually have to depress this button to enable the 500,000 count mode with this meter. This is on page 34 of the manual under section 5.1.3 transient overvoltages. So I think that what they're saying here is wrong. They say the multimeters are protected against transient overvoltages up to 6 kV with a wave front duration of 1.2 milliseconds. If you know anything about these standards, you know that that should be 1.2 microseconds and a half-time of 50 microseconds in the voltage measuring range. That'd be a hell of a punch to hit it with a 1.2 millisecond front. If longer pulse durations are expected, for example, when conducting measurements at transformers and motors, we recommend the use of our KS30 measuring adapter. It provides protection against transient overvoltages up to 6 kV with wave front durations of 10 and half times of up to 1 millisecond. So I ended up writing Gossen about this. They ended up responding, "Thank you, Joe, for your email. I just checked the article KS30 and it was discontinued several years ago. This was a mistake in our manual and we will correct it ASAP." Of course, I downloaded this manual probably 3 weeks after I'd sent out this email and it never did get corrected. So just be aware that this module that they're referring to in here is no longer available. I also asked them about the M248 not having conductance. They said, yeah, it's definitely not there. So they were saying again, if you wanted conductance, you're going to have to go with the energy. But again, that's going to take the resolution of the meter from 310,000 down to 60,000 counts. I did also ask them because they had the link to Dave's video right off of their website. And so I wanted to know about that resistor. And so I said I watched the video and the link provided. He shows that 1/4 watt axial resistor soldered to the backside of the circuit board. Was this meter indeed a prototype? And unfortunately, Gossen never wrote back. This is looking at page 35 of the manual, and this is the frequency measurement input. And you can see here there's this note. It says, "Attention, the applied signal voltage may not exceed 5 volts." They don't tell you why, but basically the meter has a separate selection like this one for hertz. And you know, I could see somebody taking the knob, switching it to the frequency input, plugging this thing into their AC outlet and trying to measure the wall frequency. And this thing is given this big attention thing here saying don't exceed 5 volts. So I don't know what that really means. You know, do you damage the meter if you put more than 5 volts into it? You know, maybe. The manual doesn't say anything more about it. But I don't like seeing this attention here. It's hard to believe that a Gossen would make a meter that would be that weak. The only thing I noticed about the pictures of that meter is they actually show that is megahertz. You know, so here on Dave's meter it would show hertz. But you look at the spec and it says measures frequency up to 1 megahertz. I mean, to me, that's not like megahertz. Some of the meters I've looked at, if you follow my videos, would read up past 100 megahertz. Another interesting thing on this page is when you look at the duty cycle, they show that from 15 hertz to a kilohertz, it can read 2 to 98%. Up to 10 kilohertz, it can go from 5 to 95% duty cycle. So there are some limitations on the meter reading the duty cycle. Another nice feature with this 248A is they also offer a 248B. It looks like it's the exact same meter, except it also has a Bluetooth interface. So another meter that I've got that has a wireless interface is this SEM DT9939. I purchased this from Ruby Electronics for $120. Of course, they raised the price shortly after I purchased this. It's now, I think, $160, but still that's about half the price of what X-Tech sells their meter for. So for me, that feature is quite appealing. So you can see that they're allowing you to connect this to a PC, smartphone, tablet PC, but they also offer LabVIEW support, I think. It's a little difficult to tell, but you can see here, this is how to activate it. It looks pretty straightforward. If we skip forward a few pages, this is page 62, we can see here it states the wireless data exchange via Bluetooth is an alternative to the optional IR USB cable connection using the USB extra accessory. They talk about needing a Class 2 Bluetooth module, and they talk about remote control is identical to corresponding communication via the IR USB connection. They also have here under terminal program for the PC, indication and evaluation of the measured values received via the Bluetooth adapter can be affected via a terminal program. So I'm assuming that you don't actually need any software to communicate with this meter. You could actually do it with a dumb terminal program. So I'd mentioned that they offer LabVIEW support. Of course, the SEM DT9939, if you watch my videos, you realize I've written quite a bit of software for this meter using LabVIEW. And I'd probably do the same thing with this Gossen. So this is one of the function calls that's in the library, and this is just read status. And you can see this function basically reads out 4 bytes from the meter. So if we look down here, it says, this VI queries the instrument status. Note, bytes 3 and 4 are reserved. And this is all the help you get. So I know that these 2 bytes are reserved, but what do these 2 bytes here do? Is there something unique about each bit of those? Where's that defined at? So you would expect there would be a manual that would go along with this, and you would think it would just be included with the library, but there isn't anything. So I've written Gossen about that, and unfortunately they never responded. This is looking at the spec sheet for the meter, and again in the 300 millivolt range, this will read down to 1 microvolt resolution. Of course, both the Unity 181A and the Bryman BM869S can read down to 1 microvolt as well. But what I really like here is the specifications for the accuracy of this. So they actually start out with a plus or minus. Imagine that. So they tell you right off the bat it's plus or minus. So then it's got a percent of reading. This is the RDG. And then they also throw in plus the percent of the range. This is the MR. And then plus some number of counts. So it's very clearly defined for accuracy. Most of the meters I look at, when you start looking at the specifications, I really have no idea what the manufacturer means. It's really kind of up to you to figure it out, I guess. You know, if you buy a real piece of test equipment, they're going to nail that stuff down pretty tight. And I think Gossen, at least in the specification, did a very good job calling this out. So we can see it can read down to 1 nanoamp. And it can also read down to 1 milliohm. You notice under frequency, it can go 300 hertz up to 1 megahertz. If you're reading the frequency in the volt mode, it can go as high as 300 kilohertz with a 1 hertz resolution. And in the lowest range, at 300 hertz, it can read down to 0.001 hertz resolution. So I don't think I've actually had a meter that would read down at that fine a resolution. For the capacitance modes, it can read down to 1 picofarad resolution in the 3 nanofarad range, and it looks like it can read up to 3 millifarads. This table on page 61 is giving you some of the response times for the meter. You can see for a 30 mega ohm resistor, this could take as long as 8 seconds to settle out. Continuity less than 50 milliseconds. So I could see the meter being a little bit slow. This is on page 63. And looking under measuring rate, can read 10 measurements per second, but they have here the refresh rate, and I assume this is how fast they're updating the screen. It's 2 times per second, or every 500 milliseconds. It looks like they only have 1 fuse. For one thing, using the larger fuse like this, it's going to make it have a much lower burden voltage. The other thing is if you're trying to measure like an amp circuit with your expensive 500 milliamp fuse, this is probably not going to pop this big 10 amp fuse. But the thing I would be concerned about is, can the meter actually survive if you blow that 10 amp fuse? Or does it damage the meter? Just going back to page 58 in the specifications, and we're looking at the burden voltage of the meters. So of course this UT181A I had mentioned in a previous study where this had the lowest burden voltage of all the meters that I actually own. And then I also had this UT61E. Again, this is another Unitrend product. From the factory, this meter had the worst burden voltage of all the meters that I own, right next to the free Harbor Freight meter. So I made a few videos where I modified the burden voltage for this meter. Of course, this meter has all sorts of modifications to it. But let's just see how the burden voltage of this meter would compare against this Gossen. Again, this meter here from Gossen would cost well over $700. Of course, on Amazon, the UT61E costs about $50. This particular one probably has about $50 million worth invested in engineering time, and maybe an additional $50 worth of components added to it. If we look at the 300 milliamp range, this meter will drop about 200 millivolts. And you can see this drops 807 millivolts. This was after my modifications. And if we go to the 30 milliamp range, you can see it's roughly 170 millivolts. And on our Unity 61E at 22 milliamps, you can see we're dropping 234 millivolts. Again, this is very poor for the handheld meters compared to the UT181A. But now let's look at the 3 milliamp range. We can see it has a drop still of 170 millivolts. Of course, when we start looking at the 2.2 milliamp range on this modified UT61E, we're all the way down to 23 millivolts. So this modified UT61E will definitely outperform this Gossen. At the 300 microamp range, you can see still 170 millivolts. It's hard to believe it would be that high. In our 220 microvolt range, we're only dropping 2.37 millivolts with this 61E. We can see here under electrical safety, it meets the standard 61010. It also meets the 610-326. So this meter should survive my little grill starter, let alone the new ESD gun. And it looks like they support 2 equivalent rechargeable nickel metal hydride batteries, which is fairly nice. So at one point Gossen had purchased Durans, and so I ended up writing them same kind of questions that I was writing Gossen directly about. So I started out just asking, I'm looking at the LabVIEW drivers on the Gossen's website. Page specifically states that it's for the MetraHit and the Metraport multimeters with infrared interface. Does this statement mean that the Bluetooth interface is not supported? Manual seems to make no distinction between the two. I said looking at the code, there's no documentation about the stat. And my big question to him is really, are there calibration houses in the United States that can perform an alignment on one of these meters if needed? If so, could you please provide a list? I did get a response back. It said they would look into the Bluetooth support. I'll also check into the programmer's manual, and that they would handle all the calibrations for the Gossen Metrawatt. So I responded back to them, thanks for the fast response. I don't think calibration be a problem. To be clear, what I'm looking for is companies that would have the tools required to align the products without the need to ship it back to the factory. The idea here would be that I want to know if the meter would have to be returned to Germany or not for an alignment. So I get a response back. As mentioned in my previous email, Durans handles all the MetraHit calibrations here in the United States. It says they won't supply the tools to calibrate the equipment. We are the sole source for calibrations here in the USA. So this is the second response about the calibration, but no mention of alignment. So I basically wrote them and said that it doesn't sound like they understand that there is a difference between the alignment and calibration, and that the terms are not interchangeable. Of course, they respond that they fully understand. It says the Gossen design is proprietary. They go on to say that GMC will not share tools or any alignment information that will circumvent our calibration or alignment of the GMC products. So then I wrote back and I said, knowing that there's a difference between the two terms, and what I'm asking for is that companies who can perform an alignment in the United States, and so far your only response has been that your company provides calibration services, am I to conclude that there are no U.S. companies who can actually align the Gossen products? So he responds, as mentioned earlier, GMC will not share the tools or alignment information that would circumvent the calibration or alignment. So, so unfortunately, I'm not sure why this guy isn't understanding my question. I said, I'm not asking anyone to share tools. What I'm asking for is basically a company in the United States that can perform an alignment. And you can see at this point, he chooses to block me. So unfortunately for us living in the United States, we would have to go through Durans to do any kind of service. So what I ended up doing was going to the California distributor, and I wrote somebody named Bob there, and I basically asked the same question. I'm trying to determine if Gossen has anyone in the United States that can perform an alignment on their handheld meters if they no longer pass calibration, or do they need to be returned to Germany for an alignment? So this guy Bob ends up writing the guy Rick, who ended up blocking me, and he basically says, can you respond? I think he must mean calibration. So unfortunately, it looks like people just are not well educated on the products. Anyway, so this guy Rick ends up writing, yes, we handle calibration and alignments here in the United States for the Gossen Metrawatt DMMs. course, you know, if he had written this right from the get-go when I asked about alignments, I would have had my answer and he wouldn't have had to block my email. So unfortunately, so far my experience with Gossen, at least as far as service and communications, I would say is very poor. I wrote Bryman all my questions. They answered everything. They've actually gone above and beyond, you know, to the point where when I explained to them what I was going to do with this meter, they were basically explaining when they thought the meter was going to get damaged. Something came up recently where a user was talking about this long-term filter delay. I ended up writing Bryman again about that. They actually gave us the algorithms that were in the meter that show how the filter actually works. So I keep hoping that Dave is going to release this 121GW and we can just forget all about Gossen. Again, you know, the products are going to be quite expensive coming from Germany, but I also have an interest in seeing how one of these things would hold up. I actually had a friend of mine write me and sent me an ad for one of those meters. And in the ad, they were basically saying that the meter was bulletproof. And he was laughing about it and saying, yeah, you really have to run this meter just because of that ad. And that was the whole point of adding the Gossen into the poll, because I think that there's more people than just myself that would like to see is what's considered the high-end meter actually really all it's cracked up to be, or the Germans blowing smoke like with that Fluke 87V.